So we've been looking at data engineering, extraction, transforming, and loading the data. We extracted it using MySQL. We can transform it so that it's cleaned and coded and manipulated to do the analysis that we want. The last phase here will be to load it into the system. Now, once we have loaded it in, the next thing we're going to want to do is we're going to want to do some exploratory data analysis. We're going to just talk in this video about some quick and dirty exploratory data analysis. So when you're cleaning and coding and manipulating, you often want to just do some quick and dirty exploration just to better understand the data and what's happening. And then in later videos, we'll get into more detail in terms of descriptive statistics and data visualizations and inferential statistics. But right now, let's just do quick and dirty. All right, so when it comes to quick and dirty, the things that we can use to get at what is happening in the data is a cross-tab. And in Excel, you might know these as pivot tables. So we can build a cross-tab or pivot table that shows us how many events happen or how many people in a survey answer a certain way to one question and a certain way to another. So how many people fall into certain combinations of variables. It drives me bananas with these. I can't see without my glasses, but the stupid ring light is constantly, no matter where I put it, glaring in my glasses. So we can create these frequency tables to help us explore if there's relationships between variables. The other thing we can do is we can look at correlation. And we can actually just, if we've coded the data, we can just do a correlation table for a bunch of data and look at, is there relationships between any of the variables? When one goes up, does the other go up? Do they move in opposite directions? Now, there are different types of correlation appropriate for different measurement scales. If you have ordinal data, you use Spearman rank. If you have interval ratio data, we use the Pearson product moment correlation coefficient. So I'll show you how to do both of them. We can run both of them with all of the data, but part of the reason that you're taking this training is so that you have the expertise to identify which one is appropriate when, because that's what gets you the job. People can run these tools, but it is the knowledge of which methods are appropriate at what time and what they tell you that is the value added that gets the paycheck. The other thing we can do for quick and dirty exploration is look at descriptive statistics. And so there is some built-in descriptive statistics in Python, just like there is an add-on in Excel that can summarize the data for you. It's really built for interval ratio data in terms of its functionality. So we can output a bunch of information that's really may not be relevant for your data set. So let's take a look. We are working through the data prep workbook. Again, just a reminder, we are at drstephpowers.github.io/BIA, and we are in the data prep here in the appendix. Of course, open and collab, save a copy to your Google Drive. And if you are joining us for the first video, go back to the last couple. We go through how to get the Excel file into your Google Drive and load it up into your collab notebook here. So we'll assume you've already done that and that you have loaded in your data set. So just a reminder here, mount your Google Drive and then load in your Excel file wherever it's located. We're using the bargain clean for this particular video. All right, so let's go back here. And we want to create crosstabs or pivot tables. Crosstab is built into pandas. So from pandas, we're going to import the command crosstab. And by importing it in by name, that means we can just call crosstab. And then what you do is you specify what is going to be your index and what is going to be your column. So in this case, we are pulling from df2. And just to remind you, in the previous video, we created a separate table that was just the coded data, so it's just numbers, okay? And so we're pulling from this df2 table here. So if you can see that if we do index equals df2 with q3 as the column for the index, then it's going to put q3 as the rows, And then columns equals DF2Q23. It's putting that here. You can see that it is the column. So question 23 across the top, question 3 along the left. So then what you can see is you can see that 8 people answered 2 to question 3 and 2 to question 23. So we might, as we look at our survey, so let's just go back to our survey, have questions particularly about how groups feel about things. So we have a couple questions in our survey about what campus are you associated from. That's question 23. We have a question here about are you part-time or full-time? Any type of demographic questions are the ones where you're looking for is one particular group feeling or acting a certain way and another particular group feeling or acting another way. And so you use the demographic questions in your crosstabs to see if you can identify any trends or relationships. So here in our data set, we were looking at question 3 and question 23. Question 3 was how satisfied are you with benefits? So the question becomes, is, question 23, do they care, depending on which campus they're on, about their benefits? Do they have more or less satisfaction depending on where they're located? We would assume that there should be no relationship between your location and your satisfaction with benefits because they're probably the same benefits for everybody. So what we can do with the crosstab is we can look at, does it look like the numbers are shifted to one end or another? And then what we're going to do in our next couple videos is analyze this crosstab and look at, is it statistically significant? Is there a dependency in these two variables? Is there a relationship between how someone answered question 3 and what location they're in? We could do a crosstab here. This is question 3 and question 23. Same question, but we're adding this normalize equals columns. When you do normalize equals columns, we go from frequency counts to percentages. And so this can help us see a little bit better what the relationship is, especially if you have a different number of people in the different location samples, right? So what we see here is that we're normalizing by column. So by column here, you can see in question 23 is north location. So what we've done is we've broken down the north location into percentages, where 100% is the column. And so we can see, is it skewed? Is the satisfaction, so if they're more satisfied, the number is going to be higher. If they're less satisfied, the numbers are going to be lower. So we look at, this is kind of equally weighted, those two directions. We look at location 2. And so let's go back to our survey, north, south, east. So north was 1, south was 2, east was 3. So here we can see that it has a similar breakdown. And the third location, a little bit different here, 3, 4. So it looks like at least locations 1 and 2, not very different in their opinions about satisfaction with benefits. So we could run some different combinations to see if we are seeing some kind of patterns or relationships, particularly with a question about opinion or behavior and a demographic question. So take a moment and create a crosstab for questions 1 and 3. Remember, question 1 asks about their priorities. So is there a relationship between their priorities and their satisfaction with healthcare benefits? And then we have question 3 and 4A. So question 3 is the satisfaction with benefits. And with our 4A is going to be whether or not they chose like health spending account, wellness account. We would assume if they want, for example, a health spending account, wellness account, and it to go up, perhaps they're not as satisfied with their current benefits. So let's run those. So take a moment, pause the video, create a crosstab. And again, normalizing it by column helps you to see. Make sure that if you're normalizing by column, that the information in the column is the demographic question. If you put the demographic in the index, then you want to normalize by the index. Okay, so it's just a good practice to put the demographic here, and then you can have yours your opinions go as the rows. So we take this, we go here, change this to Q1. And here we have Q3. Notice in this case, neither of them are demographic questions. We'll try it first without the normalizing. All right, so we notice this doesn't work. And the reason it doesn't work is that DF2 is not in, or sorry, that Q1 is not in DF2, because what we actually need is Q1A. It is in DF2. Remember, DF2 is the coded data table, and Q1 was the full list. QA is just the multiple choice. So if we run it this way, we get the information here. And you can see Q1A on the rows 1, 2, and 5. So let's go back and see what QA. Improve benefits is 1. Improve working conditions is 2. Increase pay is 5. So we expect then those who are not satisfied with their benefits are going to choose more 1. And if you want more pay or working conditions, you're probably more satisfied. So we take a look and see if that's the case. Well, we can see here 1 to 5 rating on benefits. We can see that the numbers here are at the lower end. So if you prioritize benefits, then it was because you weren't satisfied with benefits. Whereas those who are more satisfied with benefits, so higher on the scale, they wanted to focus instead on pay or working conditions. If you want to turn this into a percentage, we want to normalize equals. And so here you want to break it down so it is the percentage of those who prioritize benefits who voted different levels of benefits. So we want to not normalize over the column because it doesn't quite make sense. We want to normalize over the index here. And by doing that, what you see here is that it is going through this to add up to 1. And so for those who want to prioritize benefits, then you can see here 46 plus 15, we have 61% who dissatisfied with their level of benefits. Whereas you can see here 50% of those who want to focus on pay, 50% of those who want to focus on working conditions are satisfied with benefits. So we can see that it's skewed different directions. All right, try question 3 and 4A. So question 3 is the how satisfied are you with benefits? And 4A is the list here, the multiple choice from the healthcare benefits. So we can do this here. And we have 4A, question 3. And so we've turned it into percentages. Make sure it makes sense how you're outlining as percentages. Question 4A were the different types of benefits. So the question is, when we ask people about what benefits should we prioritize, how is that related to their level of satisfaction? And so those who are least satisfied, you can see here, live in whatever 4A number 6 is. We can see a bit of 3 and 5. And we can see here the other in 7. And so you can go back and see what is 6. 6 was drug coverage. So they're not satisfied with their healthcare benefits because not having enough drug coverage is a much bigger issue. Whereas those who want more money for wellness and health spending accounts, they're overall satisfied with their benefits, but they want more. They want a bit extra flexibility that comes with the wellness accounts and the spending accounts. So you can see how we're exploring the data with our crosstabs or pivot tables. We can run a correlation table to see if there's relationships between variables. And so if you're doing this, we want to make sure that you're doing it with the numerical columns. So here we're going to create this table. We're going to call it DF core, and we're basically just going to take certain columns from that coded, removed all the qualitative to create data frame 2, and then we can take from that just separate ones. Because, for example, if we look back at the table where we separate out 2 data frames, you know, question 2 was just 2 answers, part-time, full-time. So it doesn't really make sense to do any correlation with question 2. So you'll notice that question 2 has been excluded here. So in this case, what we're doing is listing ones where there's multiple values that are ordinal. So these are the questions that have rank. So question 3, right? Dissatisfied to strongly satisfied. And so we can go through and we can pick out which ones are the Likert scales. And we know, for example, that 10 through 15 are like the Likert scale questions. Question 8A through E, that's the one where they could rank it as 1, 2, 3, 4, 5, 6. So again, ranking anything that's ordinal, we use Spearman. And so we can basically just create a subset of data frame 2, give it a name. Notice we didn't make a copy here because we're not going to manipulate it. We're simply going to use it. So we don't need that dot copy. All we need to do is just take the subset and give it a name. So we've taken the subset, given a name, and then what we do is we do core. So core is the command for finding correlation, and then we need to specify a method. Spearman correlation is what you use for ordinal data, and Pearson is what you use for ratio data. Okay. In this particular survey, there's only 2 questions that have ratio data. And I mean, we can check their correlation. We'll do that in just a second. So here we have our subset, and then we run our correlation using Spearman. You can see that the variables on the columns and the rows are the same. So on the 45 here, we get 1s because everything is related to itself. And then you're looking for bigger numbers. So you can see, for example, question 3 and 8F are positively related and have a correlation of 0.16. We can also look for negative relationships, large negative relationships. So correlation goes from 0 to 1. The closer it is to 1, the more that they move together if it's positive, or the way they move completely in the opposite direction if it's negative. If your number is closer to 0, there's no relationship between the 2 variables. So you're looking for ones that are on the higher side, 0.4, 0.5. And so we can start to look for, here might be a relationship between some of the data. Now we said Pearson would be for the variables that are ratio. So we can use kind of the same method here and just pull the ratio ones. There's only 2 of them. And so we go back to our data set here. We had a question that was, in the last month, approximately how many hours of overtime have you worked? Question 17. And then the original version of question 24 before it was binned is the other ratio. So we could look at 17 and 14. And of course, we want to make sure that those variables are even in table DF2. So let's just go back to what we originally created. Data frame 2, 17 and the original 24 are both there. So we can then go in, and I'll just put them in order. Doesn't matter, 14, 17. So we can do that. We could run that correlation. And so here we're only looking at the relationship between 2 variables. So you get a 2x2 table with the same numbers here because the relationship between question 14 and 17 is the same as the relationship between question 17 and question 14. So here we have the correlation between 14 and 17 is 0.15. So positive People who work here longer have more overtime hours, but not super strong. So it's quite possible that the people who have the most years of experience are not the ones doing overtime, because why would you? Maybe it's more the middle group that's doing overtime, trying to move up or gain favor with management. So we can see there that there's a positive relationship, but not a very strong one. So we can use these correlations. We can have it apply to lots of data simultaneously and look for relationships. Spearman, if it's ordinal, so Likert scale, satisfied, dissatisfied, and Pearson, if it is interval or ratio. The last thing we want to look at here in this video is the describe command. And so what you can do is if you have a table that's all quantitative, it's all coded, then you can do the describe command. So here df2.describe, and we can run that. It does it to all of them. So some of them are not relevant. So for example, respondent, we don't care what the average respondent number is. You can see there were 63 respondents in the survey, but the rest of that is meaningless. And then question two, you'll recall, is part-time or full-time. So when we look at question 2, you can see the average is 1.68. Well, 1 is the part-time, 2 is the full-time, so you can see it shifted more towards full-time. More than half of the respondents were full-time. Okay. Question 3, anytime we have questions where it is a Likert scale, then we can treat it like math. And so we can see here, completely dissatisfied was 1, completely satisfied is 5. So when we look at this here, the average was 3, which is in the middle. And you can see that 50%, so half people above, half people below, was also at 3. And so it looks like it's fairly well distributed between, that most people are kind of here in the middle, and then there's some that are dissatisfied and some that are satisfied. So not really skewed based on what we're seeing here. We look at the median, we look at the mean, they're the same, they're in the middle, is balanced. All right, we look at other questions. Question 5, do you believe that your pay is similar to the same position at or another organization? Yes, no, I don't know. If we coded this as yes is 1, no is 2, and I don't know is 3, these are labels. They are not, there's no order to them. There's no ranking to them. So this is meaningless in this column. By doing a quick describe, we can just have it analyze everything that has a number, but you need to look at, is that number just a code and it's nominal? In which case this has no meaning and we ignore that column. If it's ordinal, interval, or ratio, then this describe column or this describe summary can have meaning. So for example, if we get into the Likert scale questions, 13, 14, 15, those questions said, how satisfied are you with the hours worked, the time of day, and the location? So what we have here is that was 15, that was 13, 14, 15. Okay, 13, 14, 15. So you can see here that the average is above 3, so we're skewing more towards satisfied. And if we look at the median, half of the people for 13 and 14 are above 4, so they're very satisfied. Question 15, it's a bit lower, a bit more neutral here. Now, this describes for the entire data set. What we want to do as we continue to explore is look at subsets. So for example, we want to create a summary table or look at the information where it's just the people at the east location or just the people at the west location. How do they feel? And so as we start to get into our descriptive statistics, our data visualizations, our inferential, we want to see, is there a difference in part-time versus full-time? Is there a difference in the locations where people work in terms of their opinions? So we're going to dive more into this data set as we dive more into exploratory data analysis with future videos.